Alright, just before I show you the answers, please can you just write down what question number that you got up to, or if you were able to do them, if you had the time, what question would you be able to do without using any software? So if you could do up till 4, you can just write down 4. If you could do if you could do all 10 of them, you can put 10. Thanks, Lorna. Sub-Zero Gamer 9, cool. Okay, you can still put those numbers down whilst I show you the answers. Answers are up if you just want to mark them, and then I'll talk a little bit about these questions and what we'll be doing today, and I guess when we have other sessions through the rest of the year. Thanks, Matthew. Okay, I'll give you 15 seconds just to mark your answers, and then I'll talk a little bit about them. Callum, I'm just checking. You come into the next session as well. Are you just coming to this session? Okay, with all of these, I think the lowest number that I saw was number 5. With all of these, you can, if you can do them algebraically, it's great. But if you can't do them algebraically, I guess within Desmos, the software that I spoke about last month, you can use Desmos to help you answer them. And I think with some of them, especially probably from 9 and 10, I would probably using Desmos. The rest of them I could probably do in my with working out. Maybe 5 and 6 you would do with the writing method, but one of the things that you need to be able to do with your SATs is know when to use written methods and know when to use Desmos. But if you're not capable of doing these using written methods, you've always got Desmos to turn back on. So just an example. Just an example for, let's do question, I'll start off with a simple one, question 3. So 7x minus 2 equals 5x plus 8. So 7x minus 2 equals 5x plus 8. So this is Desmos. I spoke about it last month. This is the software that you're going to be able to use within your test. It's part of the software that you use when you're doing the test. So all you need to do is type in the equation that you have. So 7x minus 2 equals 5x plus 8. If you don't have this open, I'd recommend you just get it open now. And this one has one solution, and all you need to do, you can see where it crosses the x-axis, and that's where the solution is. So the solution is 5, and if you substituted 5 into here, so you did for that one, 7 multiplied by 5, take away 2 equals 5 times by 5. So I just swapped out this x with a 5 plus 8, that would be equal to each other. So 35 take away 2 is 33. 25 add 8 is 33, so that shows you that it's a solution. So always just choose what's the most time efficient way of doing the question. Is it a written method or is it an algebraic method? So just to introduce myself, I think there's a few new people here. My name's Adam. I'm a maths teacher in the UK. I tutor quite a lot of students in the UK and around the world, mainly for GCSEs, for entrance exams like 11 plus to get into private schools, grammar schools and SATs. Now, what I've done with the test that you did last month, if you did do it, these are the results from it, and basically across the top you can see the question numbers, and these are just from the maths modules. And I've hidden the names and hidden the scores, like whether you got it correct or not, but these are the counts of how many people got it incorrect. I've just counted up which ones are the most commonly incorrectly answered questions, and then I've just listed those numbers out and just created a list of topics that we're going to go through, and I've just arranged those in a neat way for us to be able to cover as much as possible whilst we have our 1 hour sessions. So today we're going to have our main focus on algebra. We'll probably spend probably 2 or 3 sessions on algebra, 1 or 2 sessions on functions, 1 or 2 on geometry, and 1 or 2 on percentages and ratio, and that would take us to next year. So depending if your test is coming up in a few months or next year, this will just be a little bit helpful for you, but it's not going to be like a magic bullet that you can just turn up to these sessions and automatically you're going to pass. So these will just help give you a little bit of guidance, and I'll give you some help with a certain topic. I'll give you some ideas for how to answer the questions, some ideas on some knowledge on the concept. And if you have any questions about how to answer these questions, because looking at the Nat 5 and the highest test that you guys do in Scotland, it's a little bit different to how you guys do it. So if you have any questions just generally related to the maths exams that you do in Scotland or the SATs that you're going to do in the future, just let me know. But today's main focus will be on algebra. So we're going to be covering a couple of different things. So like I mentioned before, you can use Desmos for all of these questions basically. I'm going to do another one. I will do question number 8. Obviously you can just factorize it and it would be x plus 3 and x plus 4 inside the bracket is equal to 0, and x would be negative 3 and negative 4. But you can type this into Desmos and just type in y in the chat if you've got Desmos open, because you're going to need it quite a bit in this lesson. Cool, Lorna, thank you. If you haven't got it open, just get it open, either separate tab or on a separate device, whatever is good for you. Once you've got it open, I think there's a green button on the home page. You click the green button and it will take you to something that looks like this. And then I want you all to try and type in y equals x squared. And if you're not sure how to get the squared button, you look for you look at the number 6 on your keypad and you press shift and 6, and it's you're trying to get that symbol. I don't know what it's called, but you're trying to get that symbol and that'll get you the squared. So just try and type that in. And once you've done that, you'll be able to see the 2 solutions. Where it crosses the x-axis is at negative 3 and negative 4. And another way you can do it is you can see there's like a grey circle around there, and if you just hover over it, you can see the answers. And another thing that this will tell you is the minimum point. So sometimes you might get asked what's the minimum point, or interpret a graph where, for example, something like a roller coaster is going down and it's going back up. What's the lowest point of that roller coaster? So you might get asked what's the minimum point, and here it would be minus 3.5. Another thing that you can tell, there's 2 ways you can find this out, but the y-intercept, this bit on its own, the plus 12, if I look at the y-axis, the one going vertically up and down, the y-intercept is 12. So there's a few things that you can find out from here. So far I've got 3 people with Desmos open. If you've got it open, just type in yeah, so I know you've got it. Cool. Great. All right, thank you. I'm going to do 2 more examples, so number 9 and number 10. So these are simultaneous equations. Obviously you can do it written, but I think even for myself, I would just type it into Desmos because it's going to save you time. I think to solve it by hand, for me, it might take me about a minute. For you, it might be quicker, it might be slower. But I would just type in both of these equations into Desmos, and you can try and type it in yourself. So the first one, type it in with me, y equals 2x plus 3. And the second one is 3x plus 2y equals 12. Just pressing enter after I've done. and the solution is where they both cross. So I'll let you guys tell me what the answer is. What is the x value and what's the y value? Once you've got those two equations, look at the look for the point of intersection. I think my screen disappeared for a few seconds. Just checking, can everyone still see it? Okay. In the chat, can you write down what the x and y solution is for that equation? Okay, the solution for that one would be 0.85 and 4.7. So the x value would be 0.8 and the y value would be 4.7. The last one, we've got one quadratic because the highest power is a 2. If there's no power, that means it's a linear equation. This one is a quadratic. We've got two equations, so that means it's simultaneous. We're trying to solve them at the same time. So I want you to try and type in both of these equations and find what the solution is. So type in x squared plus y squared equals 13, and you might notice we talked about these type of equations last month. You'll spot something quite special about it, and this one's just a line equation. Sometimes if your graph isn't centered, you can just look on the top right hand side, press the home button, and it will show you it. And the second one, x plus y equals 5. I want you to type in the two solutions into the chat, but don't press enter. I'll give you a minute just to get your two solutions. So you should have one x and y coordinate, so that'd be your x value, that'd be your y value, and then you should have another x and y coordinate. So there's two solutions. Once you've I'll give you 30 more seconds to type them both in, and then we'll press enter at the same time. We'll see how many of you get it. Okay, I want you to press enter in 3, 2, and 1. Let's see what answers you've got. 2 and 3, 3 and 2. See if anyone wrote them as coordinates, that'd be fine as well. Cheers, Ben. Yeah, if we take a look at this, the grey dot is telling us the solutions. X is 2, y is 3, and x is 2, y is 3. So I think doing that would be a lot quicker than actually solving it. After the session, if you want to take a look at this presentation, this will be in the folder. And if you want to play around a little bit more so you can practice, then you can do so. Sometimes you might get questions like this in your SATs where you've got quite a simple equation, and the normal thing to do would be just to solve it. But then it tells you what is the value of 16x plus 8. I'm just going to write it right above this, and I'm wondering if any of you notice anything that we could do just to solve this a little bit quicker. Because sometimes you can just solve it to find x and then substitute it in, that'd be fine. But sometimes you're looking out for little patterns that they've given you in the question. So just have a think, what could be a quicker way, instead of finding x, what could be a quicker way to find the value of this? Yeah, nice. If I times all of this on the left hand side by 4, I get 16x plus 8. So all I really need to do for this answer to get the final answer is just multiply this by 4. That would give me 48. So I guess what I'm trying to show you here is, if you've got a piece of information and they're trying to ask you something that seems a bit random, try and think, instead of doing it the normal way that I've always been taught, find x and then substitute in, is there a quicker way for me to do it? Because if I did it the normal way, I think it might take me 30 seconds, 45 seconds, but if I spot that, it'll take me 5 seconds, so it'll be a lot quicker. I'm just going to talk a little bit about gradients and y-intercepts and x-intercepts. I think some of you will definitely know this already, but some of you might not. So I'm just going to give a quick overview of gradients and y-intercepts and x-intercepts. Whenever you have an equation of a line, it should always look like this. The general formula of an equation of a line is y equals something x plus c. And this number before the x is the gradient. We call m the gradient, and that just tells you how steep the line is. So if you've got a positive gradient, it's going up. If you've got a negative gradient, it's going down. And this c value is just telling you the y-intercept, so that's very important. Get a lot of questions asking you about these. So I'm just going to use these as examples. For the first one, the number before the x, the coefficient of the x, is the gradient. So the gradient here is 3. M is 3. And the y-intercept, where it crosses the y-axis, is this bit on its own. It's called a constant because it never changes. It's just this number, and it'll never change because there's no x, or there's no variable, there's no letter next to it. So the y-intercept, the c value, is 2. And if you needed to know the coordinate that it would cross at, it would be at 0, 2. So if I type this in, y equals 3x plus 2, you can see it's got a positive gradient and it's crossing at 2. So that's the first one. The next one, I've got a negative gradient. M would equal negative 5, and the y-intercept would be 6. And sometimes you might be asked, what is the x-intercept? So all that means is, where does it cross the x-axis? So there's 3 things that we can find: the gradient, the y-intercept, where it crosses the y-axis, and the x-intercept. So where it crosses the x-axis is over here. It's at negative, that'd be negative 2/3. And one way you can do that is you substitute in 0. So I would substitute y for 0. Because when y is 0 on this line, on the x-axis, y is always 0. If I substitute that in, I can find out what the x-coordinate will be. So 0 is equal to negative 5x plus 6. Just solve that, so 5x equals 6. And x would be equal to 6 over 5. Yeah, and if I take a look, 1.2 is the x-intercept. So the next one, I'll do it a little bit quicker. M would be 2/3, this bit for the x. The y-intercept will be negative 7. And if I wanted to find the x-intercept, I would substitute y equals 0. So maybe if you might know m and c, but you might not know how to find the x-intercept, you just substitute y equals 0. For number 4, m would be negative 4 over 5. The y-intercept would be 1. And if you wanted the x-intercept, you can use Desmos or just substitute y equals 0. This one is a little bit different. M is negative 2, and there's no y-intercept, so I could really write plus 0 or it's crossing at the origin. So this one is just a downward slope, and it's crossing at the origin, so it's going down by 2 every time. I'm going to give you a few questions based on that. So I want you to find the gradient of these, and I want you to find the y-intercept. And it's up to you how you want to do this. You can use Desmos, or you can substitute in y equals 0. I want you to find the x-intercept. Just going to give you 2 minutes on this. For this last one, it's not in the form y equals mx plus c. All you would need to do is swap these two around if you really needed to. But the coefficient of the x is 1, negative 1. So the gradient is negative 1, it'd be going down. And it's a y-intercept of 9, so c would be equal to 9. If I substitute 0 in, so 0 equals 9 minus x. So x is 9, so that would be 9, 0. So that's all the answers to that. I'll just give you 10 seconds just to mark it. Right, we're going to do a few harder examples now. So these you might be able to see that they're not in the form y equals mx plus c. So there's one thing that we need to do is just rearrange them so that they have y as the subject. So we're trying to make this y on its own. This one is quite simple. We can just divide through by 2. So we have y is equal to, I divide everything here by 2, so it's 2x plus 6. And then you will just find the gradient and the y-intercept from there. This one, I would need to move this 6x over first. So I've got 3x equals, I'll write it as minus 6x plus 9. Divide everything by 3, so I've got y is equal to minus 2x plus 3. This one, I think I would move this minus y over to the other side. So I've got 7x minus 2 is equal to y. And you can find your gradient there and your y-intercept there. This one is a little bit different. It's just a y equals minus 1. So you might notice that this will just be a horizontal line. So that's my y-axis, so that would be a horizontal line at y equals negative 1. It would look like that. So the gradient of that is just 0. There's no steepness of that line. It's not going up and it's not going down. And the same with that next one, x equals 5. That's my x-axis, and if I go along to 5, it would be a line that looks like this. So it's just a straight line. It's not going up or down. It's not increasing or decreasing. So there's no actual y-intercept for that one. There is a y-intercept for this one. That would just be negative 1. So that's just something to look out for. I'm going to give you these questions. So I want you to rearrange them to make y the subject. And then I want you to try and find the gradient and the y-intercept of those. So rearrange them to make y the subject. And then you're trying to get the gradient and the y-intercept. This one, I would expand out this bracket and then add 5 on to the right hand side. So m would be negative 3 and c is negative 1. For that last one, m would be 5 over 2, and C would be negative 5. Just give you a few seconds just to mark the ones that you did. If you have any questions about any of them, just let me know. I appreciate if some of you are doing hires right now. Some of you might find this a little bit easy, but there's some students in here that are doing Nat 5s that might not have had as much algebra experience as you guys. But as the lessons progress, it'll get more and more difficult. Okay, we're going to look at this question. I'm just going to do a quick explanation on transformations, and then I'll let you have a go at this question. So it says the graph of y equals f of x plus 14. So just a quick explanation here. If you've got a transformation, and this one is y equals f of x plus 14, if it's outside of the bracket, that means it's affecting the y-axis. So that means it's going to move up or down. Because this is plus 14, that means it's moved up by 14 units. If it's on the inside of the bracket, so let's say for example it's y equals f of x, let's put plus 5, this is affecting the x direction, so it's going to move left or right, but it's the opposite of what you're expecting. So if it's on the outside of the bracket, it's affecting the y-axis, and it's exactly what you're expecting. If it's plus 14, it's going to go up by 14. But if it's on the inside of the bracket, it's affecting the x direction, left and right, and it's the opposite of what you're expecting. So this graph would go left by 5 positions. So in this one, it's saying we've got a graph and it's been moved up by 14 positions. Which equation defines function f? There's 2 ways that you can do this just by looking at the graph. You don't have to. One way you could do it, you could type all of these into Desmos and you can see which one matches up. But that would be the smart way. 2 things that we can look at is, one thing is a gradient. So we can see we've got a negative gradient. I'm not going to work it out because that would take time. Because it's going downwards, it's going to be a minus, and all of these are minuses, so I can't look at the gradient. Next thing I can look at is the y-intercept. So here, the y-intercept is 2. And it told me we had a graph and it's been moved up by 14. So which of these have been moved up by 14? You can write your answers in the chat. Don't press enter. Just give everyone about 20 seconds to have a think. Which of these would it be? Okay, you should have a letter typed in the chat. Even if you don't have a letter, you can always guess. And you can press enter in 3, 2, and 1. Let's see what you've got. So we've got 3 people that have said B. Calvin said C. I actually haven't seen the right answer yet. So B and C is not correct. Eddie, well done. You were the first one to get it correct. So I think the people that said B, they thought, they thought that the function of f of x was drawn, but this isn't the function of f of x. This is the function of f of x plus 14. So we need to think that because this has been moved up by 14, what was it originally? It would have gone down by 14. So it would have been around about there, and it would be this equation where the y-intercept would be negative 12. So well done to Eddie for not going along with what everyone else was saying. I'm going to talk a little bit about parallel and perpendicular lines. There's 2 things that you need to know. So I've already talked about how to find the gradient and the y-intercept. To find a parallel line, if we know the grade, I'll first explain what parallel just means in case you don't know. Parallel just means if I have one straight line, a line parallel to that would be another line going in the same direction and it won't touch with each other. So the gradient of both of these lines will be equal to each other. They'll never touch each other, they'll just have the same gradient. They could have a different y-intercept, but the gradient will be the same. So a line parallel to this line would be would have a gradient of 3. So I'm just going to draw this onto Desmos so I can help you visualize it a little bit. So I've got y equals 3x plus 2, and I could have any equation. I'll press the home just to center it a bit, and I'll delete this one. Any equation that has y equals 3x will always be parallel to it. So you can see we've got these two lines that are running along each other. And I can change the y-intercept, so I'm going to move it up a little bit. It's gone above the blue line, and I could bring it below the blue line again, but it'll never touch as long as the gradient is the same. So that's the thing that you need to remember. If two lines are parallel, they have the same gradient. So for number 2, the gradient is -5. So if I wanted a line that would be parallel to that, it would have to have a gradient of -5. Next thing that I'm going to talk about is perpendicular. So if you have two lines that are perpendicular, you've got one line, and the line that would be perpendicular to it would be a line that crosses it at a right angle. So there's right angles here. And the way that you remember it is, if I know the gradient of the first one, the gradient of the perpendicular line is the inverse reciprocal. And if you're good at indices, you'll probably know what reciprocal means, because you might have done questions like 5 to the power of -2, where you have to flip it and then you square it. So I'll take a look at number 1 first. To find the inverse reciprocal of this, so these are my parallel gradients. The inverse, because this is positive, it's going to become a negative, and the reciprocal just means I need to flip this fraction. If I wrote 3 as a fraction, it would be 3 over 1, and if I changed it, it would become 1 over 3. So if it's positive, it becomes a negative, and then you just have to flip it. For the next one, I've got a negative, so it's going to become a positive, and I need to flip it, so it's going to become 1 over 5. Perpendicular. Number 3, we've got a positive, so it's going to become a negative gradient, and it'll become 3 over 2. I'll just show you an example using number 3. So this is our original equation. Y equals 2/3 x minus 7. That's my original equation, and I want to draw a line that's perpendicular to it. So I would have y equals, because it's a positive, it's going to become negative. I need to flip it, so it becomes 3 over 2, and x. And you can see already we've got perpendicular lines. It doesn't matter where the y-intercept is. It could be plus 10, it could be plus 100. It doesn't matter, but there'll always be right angles here. So that's what you're looking for. Yeah, thanks for telling me, Eddie. So the first one was 2/3 x. I need because that was positive, it needs to be negative, and I need to flip that fraction. It doesn't matter where the y-intercept is. It could be 1,000, it could be minus 25.2, it doesn't matter. But there'll be right angles there. So the two main things that you need to remember is that if you have parallel lines, they're going to have the same gradient. If you have perpendicular lines, the main thing is it's going to be an inverse reciprocal. If you want to get a few examples down, you can do. I'll just give you 10 seconds to write down a quick example. If you want to do 4 and 5, what would the parallel... Give me an example of an equation that would be parallel to it, and give me an equation that would be perpendicular to it. So either you're making notes on the examples, or you can do number 4 and 5. Just give me an equation where it's parallel to that line or it's perpendicular to that line. Okay, question 4. As long as your gradient is minus 4/5 for the parallel one, so it could be y equals minus 4/5 x, minus 10, minus 100, plus 20, it could be anything, it doesn't matter. And then for the other one, it needs to be y equals 5 over 4x. For the next one, it'd be y equals minus 2x plus anything, it doesn't matter. As long as you have the minus 2, it's okay. For the other one, it has to be y equals 1/2 x plus or minus anything. As long as you've got the 1/2 x, it's okay. I want to look at this question. So it says we've got equation y equals 6x plus 18. one of the equations in a system of two linear equations is given. So this is one equation, and there's another equation that we don't know. It's going to be one of these. The system has no solution. So if a system has no solutions, that means that it's never touching each other. That means no solutions. So these type of questions come up quite often. They're quite simple once you've understood them. So either you're going to have no solutions or you're going to have one solution. And we looked at these in the starter when we had two lines that cross each other, simultaneous equations. Or you could have two solutions. You could have more, but we'll just concentrate on these, where you might have a curved line and a line that goes through them, and those 2 points are the two solutions. So we're looking for an equation that has no solutions. Which equation could be the second equation in the system? The first thing that I'm going to think about is the gradient of this one is 6. So m is equal to 6. And if I rearrange this, I would have y equals 6x plus 18. And this is a different type. This is another one. We've had no solutions, one solution, and two solutions. This is another type. If I drew both of these equations, y equals 6x plus 18 and y equals 6x plus 18, I'll just draw it here. Y equals 6x plus 18 would look like that. And then if I drew y equals 6x plus 18, it would go exactly over it. So that would be an infinite amount of solutions. So if you have exactly the same equation, it's going to have an infinite amount of solutions. So it can't be A. For the next one, we have y equals, if I rearrange it, 6x plus 22. And if I plotted both of these on, this one is y equals 6x plus 18. And this one is y equals 6x plus 22. So the y-intercept is over here, but they have the same gradient. And if you see, they've got no solutions because they're not crossing each other at any point. So that means this has to be B. If it asked for a solution with, if it asked for an equation with one solution, it would be either C or D, because both of these would cross at one point. A would have an infinite amount of solutions, B would have 0 solutions because it's never going to touch, and C and D would have one solution. So this is a very common type of question. Just need to be familiar with these type of graphs. If you're not too sure, you can plot all of them onto Desmos and this one and just see which one fits. Just going to show you how you would use Desmos for these type of questions. It's the last thing that we'll do. We've got about 5 minutes left. If you are doing higher, you're probably very familiar with finding the gradient and then finding the y-intercept and then creating an equation of a line using 2 points. Here we're trying to find the y-intercept. You could also find the gradient and go backwards with this point. So there's a few different ways you could do it. I'm going to show you how you can do it using Desmos. So just everyone have Desmos open at the same time and you can do it with me. I'm going to clear out my previous equations. I'm going to press this plus button, and if I click table, I'm going to type in both of these coordinates. I've got 1, 4 and 5, 2. So 1, 4 and 5, 2. And then if I look here, it kind of looks like a checkered flag, but it's just a line with dots around it. If you press that button, it should create a line going through those 2 points, and it will say linear regression, and just below equation it tells you the equation of that line. Y equals minus 0.5x plus 4.5. Y equals minus 0.5x plus 4.5. This question is asking me for the value of B. What's the y-intercept? It's 4.5, or you could also see on the graph it's 4.5. So I guess what I want you to practice here is just getting used to, if you've got two coordinates, obviously you can use the algebraic way, but I want you to also have another skill where you can just use Desmos. So click the plus button, click the table. I want you to all try number 2, where you've got these two coordinates, 3, 7 and 6, 4. And then you're trying to find, you can find that equation and you can find the y-intercept for that equation. If you've done number 2, you can do number 3. You can do as many as you want, but try and do number 2. If anyone's having any issues with anything, just tell me. I'd recommend you practice this a little bit after the lesson, just so you don't forget, so you get comfortable with using it in a test. So this one click the plus button, click the table. I'm going to type in 3 and 7, and I can use the tab on the keyboard to move to the next one, and then 6 and 4. Press the checkered flag, the line, and it'll create the equation y equals negative x plus 10. And we want the value of b. In America, sometimes they use b instead of c. In the UK, we use c typically for the y-intercept, but they might say b. So the y-intercept here is 10. The coordinate of that would be 0, 10. I'll let you do 3, 4, and 5 for homework, or you can just use it to practice. And we've just finished the hour, but if you take a look on the last few slides, I've put in a few questions that are quite similar to the type of questions that you get in an SAT. So if you want to have a look through them, they might be testing you on most of them will be testing you on things that we've done in the lesson. Some of them will be testing you on stuff we've done in the lesson and stuff you might already know. So there might be something on Pythagoras, mean, and it might just be testing your general knowledge and how you answer a SAT question. If you have any questions, I'll be here for 2 more minutes if you want to type them in. Otherwise, I think you've probably got something to do, and I will see you next month. But this presentation will be in the folder, and you'll also get a link to the lesson if you need it.